Okay, this is the last part of section 4.8, and in this section we're going to go back to solving quadratic equations. So we're going to find imaginary solutions to quadratic equations. Okay, so again, like I said, we're going to go back to solving quadratic equations, which you've done this before. This is nothing new as we're going through. The only thing that's different about this is that you're going to have a possibility of having a negative underneath the square root, and we're going to have to evaluate that properly. Okay, so number one here says to use any method to solve the quadratic equation, and I would suggest to use the quadratic formula because it works with any equation, whether it's factorable or not, whether your middle term's even. I would just use quadratic formula to solve all these. Okay. Number two says if you have a negative number underneath the square root, then you must simplify the root to make it an imaginary number. You cannot leave negatives underneath the square root. Okay. So anytime we have a negative underneath the square root, we've got to make that take that outside of the square root and you turn that into I. Alright, so let's take a look at some of these examples here quickly, and I'm going to write up here again the quadratic formula. So as we go through on this, we kind of remember, it's been a little bit since we've had this, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, and that's how we can solve any quadratic form that we have. Remember, we want to try and find the discriminant first of b squared minus 4ac, and then we plug that in, and so forth and so on. Okay, so let's take a look here at number one. We've got 2x squared plus 32 equals 0. And the first thing again that we want to make sure we do is we want to make sure that this equation is always set equal to 0. So then we can identify A, B, and C. And it's already set equal to 0. So in this case, we've got A is going to be 2. B, there is no x term there. There's no middle term. So B in this case is going to be 0, and C is 32. Okay. So as we go through and we solve this equation, I'm going to plug this into the discriminant, b squared minus 4ac. B squared is 0 squared minus 4 times a is 2 and c is 32. And as I look at this, 0 squared is 0 and minus 4 times 2 is 8. 8 times 32 is 256. So the discriminant here is negative 256. Okay, so now we can take that number and we can put this into solving this equation. So the opposite of b, again, it's still going to be 0 plus or minus the square root of the discriminant, which is negative 256. And we're going to divide that by 2 times a, and 2 times 2 is 4. So really we have plus or minus the square root of negative 256 over 4. So as we look at this problem here, remember we can take this negative out. This negative underneath the square root will move out and become an I. So we've got this is positive and negative I times the square root of 256 divided by 4. And if you look on your multiplication chart, the square root of 256 is a perfect square. So the square root of 256 is 16. So this is going to be equal to positive and negative 16i divided by 4. And I can take 16 and 4 and reduce them. 16 divided by 4 is 4. So this is going to be positive and negative 4i. There's your answer. Okay. So we now have looked at problem number 1. And that's an example of a problem without a middle term. Okay, now let's take a look at problem number 2 here now. 2x squared minus 3x plus 5 equals 0. Again, the first thing you got to check to make sure is make sure your equation is equal to 0, and it is. So we can figure out A is 2, B is negative 3 this time, and C is 5. Going to plug it into the quadratic formula. Okay, so we're going to use b squared minus 4ac first. So we've got b, which is negative 3 squared minus 4 times a is 2.
Mr. Tor
and c is 5. So we've got 9 here. Negative 3 squared is 9. 4 times 2 is 8 times 5 is 40. 9 minus 40, and we've got negative 31. Okay, so now again we're going to put this into the quadratic formula. The opposite of b is positive 3, plus or minus the square root of negative 31, all divided by 2 times a. 2 times 2 is 4. Okay, and you'll notice on this one, can we break down the square root of 31? There's no perfect squares that go in there because that's a prime number. But we do have to take out, again, you have to take this negative out of the square root. So I've got x is going to equal 3 plus or minus. To take out that negative out of there, I'm going to put an I out front of that square root. So 3 plus or minus I times the square root of 31, all divided by 4. And I can't break anything else down. You're finished. You're done. That's it. Okay? So that's example number 2. Now let's take a look here at number 3. Okay? Again, first thing you always have to check to make sure is this equation set equal to 0. Now on number 3 it's not that way. So I have to make it set equal to 0. So I'm going to go ahead and subtract 4x and I'm going to add 7. Subtract 4x, I'm going to add 7. So I end up with 2x squared minus 4x plus 7, and it's going to equal 0. Okay? So as I look at this now, I've got it equal to 0, so I've got a is 2, b is negative 4, c is positive 7. And I got to use the discriminant. Okay, I do the discriminant first. So the b squared is negative 4 squared minus 4 times a is 2 times c is 7. Okay, negative 4 squared is 16. 4 times 2 is 8. 8 times 7 is 56. So I've got 16 minus 56, which this happens to be negative 40. Okay, so again, I'm going to plug it into the quadratic formula. The opposite of b is 4, plus or minus the square root of negative 40, all divided by 2 times a, which a, again, happens to be 2. It's not always going to be 2, so 2 times 2 is 4. Okay, so what perfect square goes into 40? Well, I know that 4 happens to go in there, so I've got x equals 4 plus or minus this negative symbol right here. I'm going to move out, make it an I. Goes out in front, times the square root of 4 times 10, all divided by 4. So then I'm going to simplify here a little bit. I got 4 plus or minus the square root of 4 right here. Square root of 4 is 2. So I'm going to put that out front of that I. Plus or minus 2i. That takes care of the 4 underneath the square root. And 10 is left underneath. And divide that by 4. Okay. And now when I finish up here, again, as you look, all 3 of these numbers are all divisible by 2. So if I break them down, divide them by 2, 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so I'm just going to have an I times the square root of 10, and then I'm going to divide that by 4 divided by 2 is 2. There are no more perfect squares that go into 10, and you're finished. Simplified. Okay? So we've got number 3 down. Let's take a look now at number 4. Okay, number 4. Again, first thing you want to check is the equation set equal to 0. It's not. And you'll notice that your x term is negative, your x squared term is negative. So you know what? I'm going to move these both over to the right. So I'm going to go ahead and add 3x squared and subtract x. Add 3x squared, subtract x. Okay? So I'm going to get 3x squared minus x plus 3 equals 0. So I've got everything equal to 0 now. A is 3, b is negative 1, and c is 3. Okay, got to put it into the discriminant again. B squared minus 4ac. So we've got negative 1 squared minus 4 times 3 times 3. This is 1. 4 times 3 is 12. Times 3 is 36. So 1 minus 36, which is negative 35. Okay, so now I'm going to put that into the quadratic formula. The opposite of b is 1, plus or minus the square root of negative 35, all divided by 2 times a, which is 6. Okay, again, I cannot leave this negative underneath the square root, so it's got to come out. In order for it to come out, I got to put an I in there. So 1 plus or minus I times the square root of 35, all divided by 6. Are there any perfect squares that go into 35? There are not, and there's no other way to simplify, so this is my answer. Okay. Again, as you recognize this is not anything that we've done that's new. You've used the quadratic formula, you've solved. The only part that is new is where you take a negative inside a square root, move it out, and you turn it into an I, turn it into an imaginary number. You're taking out that square root of negative 1. Okay. All right, this concludes section 4.8, solving imaginary quadratic equations.